So in the next question, we had coordinate geometry of the line. So L is the line x plus 2y minus 6 equals to 0. The line K is perpendicular to L. So that's our first key word there. Now, if lines are perpendicular, their slopes are different in every way. So the slope is going to be inverted and the sign is opposite. So L is this line, K is perpendicular to L, and its y-intercept is minus 7. Now, if something has a y-intercept of minus 7, then the coordinates are 0, minus 7. So a y-intercept always has 0 for its x value, because if it's a y-intercept, it's on the y-axis, so x has to be 0. Find the equation of K. Okay, so to find the equation of any line, we use y minus y1 equals to m bracket x minus x1. So we need to replace, so the question really is, do we have a point that we can put in? And do we have a slope? So I suppose we do have a point. We have the x1 and the y1. So I can actually start filling that in, deal with the minus 7 equals m bracket, and that's just going to be x. Now the m, so the m is the slope. So that's the only part I haven't done yet. So what I'm going to do is, if I can find the slope of 2y minus 6 equals to 0. So if I can somehow find the slope of L, then I should be able to find the perpendicular slope, which is K. So of course, perpendicular literally means if L is coming down this way, K is meeting it like that at 90 degrees. So, okay, so how do I get the slope from an equation? Well, that's using my y equals mx plus c. So to make it easier, what I want to do is get y on its own. Now, when I get y on its own, the number with x is our slope. So I'm just going to rearrange to get y on its own. So I'm going to leave the 2y. Now, to get y on its own, I have to obviously divide by the 2. So we end up with, well, it's minus x plus 6 over 2, really. So y is equal to, now, if I want to write that in a way that's a bit easier to read, what I do is I'll write, because that's a 1, of course, so I write it as minus a half x plus, well, that's 6 over 2, but of course I can just write that, if it's okay, as 3. So I know the slope of L is, I now know the slope of L is minus a half. So immediately I know the slope of K, so this is K. The slope of K is going to be opposite in every way. So what is opposite in every way? Well, opposite of negative is positive, opposite of a half, so inverted, as I said up here, is 2. So that's why that is a 2. So when I go to write the equation of the line, it doesn't actually tell us what format to write it in, so we can accept any format, but I think what we'll do is just put it all together to one side equal to 0. So there is my K. That's K done. Okay, so then I have M and N are two lines which pass through the point of intersection of the lines L and K. So if this is L and this is K, like I described earlier, there are these two other lines. So all I know about these lines at the moment, as I read this question, is that they pass through the point of intersection of L and K. And it says 6 minus 3 is a point on M. Find the equation of M. So I don't really know yet what's happening, but I know, for example, if this is M, and for example, if this is N, then I do know that M passes through the point of intersection of L and K. But I do have another point on M. Again, I don't know where that is, but I do know that 6 minus 3 is also on M. Still going to use my x1, but I need to know, do I have a point and do I have a slope? So just like in the last question, I need to replace, so I'll highlight it, I need to replace this one, this one, this one. Now, I'm kind of spoiled for choice here because I have 2 points on M. I have the place where they intersect, where L and K intersect, and I am also told that 6 minus 3 is on M. Now, because I don't have the point of intersection at the moment, I think I will go ahead and just use the 6 minus 3 as my x1, y1. So I end up with y minus 3. I'll worry about this case 6, x minus 6. So we're nearly there, but we don't have the slope. So how do I get the slope? Well, to find a slope, I can do rise over run if I have a good graph. In this case, I don't, obviously. So I'm going to have to use my slope formula. So let's write that down. M is equal to, and we have y2 minus y1 all over x2 minus x1. So to do the slope, I would need 2 points. Now I do again have my 6 minus 3, but I don't have this intersection point yet. So what I'm going to have to do is I'm going to have to solve them simultaneously. So I use L, which is x plus 2y minus 6 equals to 0. And I set that up with the line that I just found out, which is 7 equals to 0. So the usual story with simultaneous, I need to get either the x's or the y's to match, but have opposite sign. So I think kind of an easy thing to do would be just to double the bottom line here. So I end up with x plus 2y minus 6 equal to 0. 4x minus 2y minus 14 equals 0. They cancel. 5x minus 20. So that's 5x equals 20. So x is 4. And if I know x is 4, well, I can go right back to the top and fill that in. So I end up getting minus 2. So I end up getting 2y is equal to 2. So y is 1. So now I have the point of intersection 4, 1. So that is going to be my other point. So I'll write that over here, 4, 1, and I'm going to call that my x2, y2. So filling this into my slope, I have 1 minus 3 all over 4 minus 6. So I end up essentially with 4 on top, minus 2 on the bottom. So my slope is minus 2. Now, if my slope is minus 2, well, then I go right back to where I was. And in the place of m, I'm going to pop in to that position, minus 2. So I have y plus 3 is equal to minus 2x plus 12. And again, it might be nice to put it all here together on the one side. They haven't told us what format, but I think that makes sense to put it all here together. So 2x plus y minus 9 equals to 0. And we're done. And then finally, find the two possible equations of n. So n is this other random line that goes through the point of intersection if the angle between m and n is 45 degrees. Now, we did a formula, you might remember, in the log tables. Tan of the angle is equal to plus or minus one of the slopes minus the other slope, all over 1 plus one slope and the other slope times together. So in our case, we know the angle between them is 45. So 45 is going to go in there. We know what the slopes are. So we know one of them is minus 2. And we don't know the other one, sorry. So that's what we're going to try and figure out. So find the two equations, but to do that, I need the slope first. So I'm going to fill in my minus 2 here again, because remember up here, we found out the slope was minus 2. And we don't know what the other one is. So the tan of 45 is 1. So that makes it nice and easy on this side. I'm going to just write it as 1 over 1 because of the fractions. Now, 1 is plus and 1 is minus. So at this stage, I might start splitting this. So I'm going to use the plus first, minus 2 minus m2. So I'm kind of just doing the plus along the top line there, which obviously has no effect on anything. And then the other possibility is, now this time I have to apply the minus. So that minus has to be applied here, positive 2. It has to be applied here, positive m2. And then we obviously don't need to worry about the bottom because I've already applied the sign on top. So then we cross multiply. 1 minus 2m2 is equal to minus 2 minus m2. So we group it together. So if we group it together, we have 1 plus 2. So we have 3 on this side minus m2 plus 2m2. So that's just 1m2. So one of the slopes is 3. One possibility of the slope of n is 3. When we do the other side, exactly the same method, cross multiply, bring it together. So we're going to get 3m2 on one side, and on the other, we're going to have minus 1. So the other slope turns out to be minus 1/3. So, sorry, that's a bit squashed, so I'll just highlight that there. Okay, so now that I have the two slopes, we're looking for the two possible equations. Okay, so we know that n passes through the point of intersection of K and L. So we're going to use that fact again. So what did we say that was? Let's go back up here. So 4, 1. So 4, 1 was the point of intersection of L and K, which n passes through. So in one scenario, we're going to use a slope of 3 and the point 4, 1. And in the other scenario, we're going to use minus 1/3 and 4, 1. So y minus y1 equals m bracket x minus x1. So again, just same formula again. So I'm just speeding this up a little bit. So y, we put it all on the one side again, actually. So I will move that over. So one of the equations of n is going to be 3x minus y minus 12 plus 1. So that's minus 11 equals 0. So that's one possibility. The other possibility, y minus y1 equals m bracket x minus x1. Now, when we have fractional slope, the easiest thing to do is move the bottom guy over. So in other words, 3 bracket 1 y minus 1, and I have minus 1x minus 4 here. So 3y minus 3 is equal to minus 1x plus 4. And again, bring it all together, 1x plus 3y minus 7 equals 0. So my final answer for the two possible equations of n are 3x minus y equals, take 11 equals 0, and x plus 3y minus 7 equals to 0. And that's the end of that particular one. Okay, so I'll stop the video there.